All right, so welcome everyone. We're going to start looking at homework number 4. And so, you know, same thing as always. He wants our homework to make sense when he reads through it. It's not confusing or anything. So the first thing that it's asking is for us to find how the percentage of young people in the population, which is the variable pop.18.24 in 2004, affects abortion rates or abort rate. Evaluate this relationship using methods taught to you in class. So the first thing when approaching any of these is you need to determine what's your X, what's your Y, what's your dependent variable, what's your independent variable. And so the number one thing to always remember with that is X causes Y, or your independent variable causes the change in the dependent variable. So here you're seeing how the percentage of the people in the population, this POP 18 to 24, affects abortion rates. So POP 1824 is your independent or X variable, and abortion rates are your dependent or Y variable. Did anyone have any questions about that?
So POP is X?
Correct. So like I said, we got our variables, which is POP and abort. And so what we're going to do is we're going to create this mod.1, which is using the linear model of abort rate space the, I don't know what that little squiggly line thing is called, space POP 18, and then the data is within the states. And then you're just doing the summary. So and so when you run that, you're getting this information right here. And so the first part I put down is part A is just report your code. You need to show Professor Menchaca that you know which code to use, which was this linear model, or whatever LM stands for mod 1, and then you're doing a summary of mod 1. So then it goes into evaluate this relationship using the methods taught to you in class. The two methods we were taught in class is p-value and examining R squared. And so when we look here at the information, we have our p-value down here for population, which it has 3 stars, which that means that it is highly significant all the way to the 0.999 confidence interval. So it is highly significant. And then we have our R squared, which is 0.35. And remember, R squared goes from 0 to 1. The closer to 1 it is, the higher it is, then the more strong the R squared is. And so what this is actually saying, the R squared, is how well does these variables explain the relationship. And so this 0.3511 is saying basically 35% of all the situations are explained by these variables or this relationship between these two variables. So that means it explains about a third of it, 65% it doesn't explain. But as you said before, when you're using real world data, like a 0.35, that's actually decently significant. So for mine, what I just realize this. Okay, there we go. What I wrote is that while it's still closer to 0 than it is to 1, this is still a decent R-squared weighting for real life data. So basically I evaluated it saying that this relationship is significant because of these two things. Are there any questions on that?
Mm,
All right. So now we'll go into the marginal effect. Who doesn't understand what a marginal effect is or what he is asking for when he says, what is the marginal effect?
I don't really get that.
Okay. So a marginal effect is simply, it's like a word problem of math. Like, you know how you can express like a math problem out by using like just the numbers, or you could, get those crazy annoying word problems that, basically for you to solve, you have to pull all the math out of the words and then put it into an equation. And then when you finish it, you have to put all the math back into the words. It's kind of like that. So what you're looking for with that is a way to basically, it's a verbal expression of what the slope is doing. So right here, when we look, we have to remember is that, so under this estimate or the coefficients, here, this one that is the intercept, that is the y-intercept. We're not super concerned about that unless we're writing out equations. But what we're concerned about is this one next to our independent variable, that is the slope of this line. And so what this is saying is that for every 1% change or 1 unit increase in population between 18 and 24, we are having a 5.938 unit decrease on the dependent variable. So when you write it out, like here is what it is. For every 1 unit of increase in population being between 18 and 24 years old, we have a 5.38 decrease of abortion rates of the state. And so the reason why this is a decrease is because if we look here, it is a negative number. So as this, which is population, is our independent variable, as it raises 1 point, it causes a negative 5.938 point change on the dependent variable. And that's just, this is how you're writing it out in one sentence.
Okay.
Any questions or anything?
So far, so good.
All right. All right. So then on to the third part of it. The third question. So those are the first 2 questions. Those are super easy. This is the one that I've spent most of the day working on. And I've watched numerous videos to try to make sure that I know how to set up this problem properly. I just was a little confused on how to evaluate after the fact. So that's what we're going to kind of work through all this and kind of see what we all think together. I think I did way more of a deep dive than I needed to, and he's probably looking for a super simple, easy answer. And I'm probably just too scared not to have every little piece. And so I probably did way more than I needed to. But so first thing is evaluate the control variable, use the methods in this class. So here is where we need to modify. Okay, so using the regression above, control for the percentage of women in the state legislature, or womenledge.2007. So what this is doing is this is when you're controlling for one of the variables. So basically is what you're doing is in this equation, you're making sure that the variable of women in legislature doesn't change. And so, so the way that the code is written out is now we're making a mod 0.2, and it's that same LM, and it's abort rate, the squiggly line, population 18.24, but then it's plus Women Ledge 2007, and then the summary mod 2. And so when we do this, now you'll notice, I'll do this so you can see both of them. So now you'll notice where on the first one, how we just had the intercept and then pop. Now we have intercept, pop, and Women Ledge. And so one of the first things that kind of stands out is we have the p-value of Women Ledge is 0.0549. So that means that it is not within the 0.05, or it is not statistically significant. The other things that we're going to look at is, so when we had just population on its own, it was for every one, the slope was a negative 5.938. Well, now we have a negative 5.2474. So it did actually change that number, but only slightly, about 70.7. So not a whole lot. Then we're also looking at the R squared. It actually raised it about 5%. So this is where mine gets all crazy. I have all the information that I just kind of pointed out to you on here between the two. And so are there any questions about setting up this second formula before we go on?
So he wants us to put, wait, for mod 2. Okay. I think we're fine. Sorry.
So I just want to make sure everyone understands. So this is basically still seeing how the population is affecting the abort rate, but controlling for Women Ledge. And so you're just controlling for one variable. So when we go into this, so one of the ways to look at this is to put this into an equation. And so what that equation is, basically is you have your intercept plus, you know, the slope on your variable, and then and actually these should have X and Z technically, plus what you're controlling for. So, and when you look at this and you are going to read it, this is basically just, these are more marginal explanations of what's going on. So for this one, it's saying for every 1 unit of increase on population, which is X, we have a 5.24 decrease for abortion rates of the state when we control for the number of women in legislature. So does everyone understand how we took these numbers, put them into the formula, and then how you read them this way?
Kind of.
So, and kind of like what you're going to be doing is when you're controlling for women in legislature, you're basically assuming Z equals 0. So you're only concerned with this part of the equation. So then the second half of this was that you would be controlling on the other side and seeing what the effect of women being in legislature are on the abortion rates. So for every 1 unit of increase of the number of women in legislature, you have a 0.26% increase on abortion rates. And this is controlling for population being between 18 and 24. So obviously we see, you know, this is saying a 5% increase versus a 0.25% increase. So by writing these out into the sentences, you can see this has a significant change, this doesn't. Does that make sense?
Yes.
All right, so then we're going to look at the p-value. So now the p-value of the population was still, you know, triple starred in the 0.999 confidence and everything. So it's still heavily significant. But for women ledge, it was the 0.059 making it not significant. And so, you know, basically saying that the number of women in legislators, it's just not a super significant variable when it comes to these relationships. Any questions there? Okay. So then the next thing, and this is where I totally think I went off the deep end on, but it also made sense to me, is remember that, and this kind of goes along with checking the p-values, is that the null hypothesis is that B equals 0. And, you know, basically that any of these, the null hypothesis of B equals 0 means that there is no relationship. That, you know, no matter what, you know, your independent variable does not have an effect on the dependent variable. That's what B equals 0 means. So when we do and this is the code, confint at the 0.95, this is getting a confidence interval of 0.095 of mod 2, it returned this, which, so we see somewhere between 35 and 88 for the intercept. And so remember, this is all where we get, like, you know, with 95% confidence, we can say that the true mean of yada yada lies between blah blah and blah blah. So you know, we got the y-intercept, which we don't really care about. We know that population somewhere between -7 and -2, cool. But then if we look at this, is the woman.2007 is, we are 95% confident that the true mean of women ledge 2007 lies between a negative 0.005 yada 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 and 0.52, which is a positive number. That means that it is possible that the true mean of women ledge is actually equal to 0 And so because it's possible that it does equal 0, we cannot reject the null hypothesis. And so because of that, because we can't reject the null hypothesis, we can't say that there is a significant relationship there. Does that make sense?
Honestly, all of this makes little sense to me, but I'm following kind of.
How about everyone else on, dudes? Is that clear for y'all?
Kind of.
Like I said, I think with this last part, testing the null hypothesis, I think I kind of went off the deep end because that was totally something that I pulled from a video that I was watching as I was going down the multiple linear aggressions rabbit hole that I did this afternoon. I was literally watching like YouTube videos on all this stuff for like probably 3 hours and trying to just better understand it.
Do we need to put the null hypothesis in our homework, or is that just something extra?
Like I said, I have a feeling that was just something extra that I did. Because the thing that I believe he's going to want you to look at is the p-values in R squared. Because he says in here, evaluate the control variable using the methods you've learned in this class and lab. The methods that we learned were checking the p-value and checking the R squared. Let me just open up the lab notes and just see if maybe there's something that I missed. Anyone remember what lab notes this was? Is it 11?
I think so.
Yeah, it looks like it. Okay. So there was the first one. That was how you control for it. Model 2, instead of being positive, is exactly what expected. Better way to understand the data. Okay. Tale of 2 regressions. So it's still just 1. Still just 1. Yeah, see, I'm not seeing anything else. Like, there was just this where he controlled for the groups. Now you can see there's negative instead of positive, exactly what you expected. Better way to understand data. Color-coded regressions, This has been a lesson important. Some of these maybe founding factors, variables, relationships, controls for each relationship. In case should you above, relations that actually causes size of variable change, and thus adding control variables and latent understandings. So, yeah, no, I'm not seeing anything else in there. Yeah, so like I said, I feel like the p-values are the most important things, p-values and then R squared. And so on this, we see that with the first one, the R squared was 0.35 or 35% of, and then it went up to 0.4. So it's basically a 5% increase. And I'm going to say that it's not an increase that increase is not significant. It's just 5%. we already said that, before at the 35, that was, pretty good for real world stats. But just bumping it up to 40 is not like a huge difference. So the last thing, which this is the one question I haven't answered yet, is evaluate the model as a whole. Did this control variable add any improvement to it? Did it help us understand the relationship in a better way? And basically, I'm going to say no, it did not. It's basically that control variable of the women in legislature. It didn't have much of an effect. It was not statistically significant, nor did it have any crazy high change on the R squared. So I'm going to say that it did not improve it. It did not improve the model, but it did tell us that the women ledge 2007 does not have a relationship, or it doesn't have an effect on this relationship. So that's the only way it helps us better understand the relationship, is we know that the number of women in legislature in 2007 have nothing to do with it.
Okay.
All good?
Mhm.
We have about 6 minutes left. If you guys have any questions or have anything you want me to go back over.
Could you go back to question 1? Can I see how you like answered it and see what you put in exactly?
Mhm.
Let me just, where is my Zoom? Okay. And then for 3, just really quick again, you went into like a whole, so you want us, do you think we have to put it in A, B, C, D, E, F, like all that, or just copy and paste?
It's up to you. Basically, when I copied and pasted, it just did that since I was already working in a list. But you don't need to. You might not need to put in all that data. You definitely want to report your R code. And then when you're evaluating it, I kind of just use that to go off of to show where I was getting my numbers and all my information from.
Okay. All right. So tomorrow you said we just have to talk about the extra credit in class. Like, how's he going to give us credit? He's just going to note down like who speaks up or whatever.
I assume, maybe he'll just try to figure out who's full of shit and didn't actually read it. And, if you say something that makes it sound like you actually read it, then he gives you credit.
Did you read it already?
Not yet. I'll probably read it tomorrow morning. So I had a bunch of wedding planning stuff going on this weekend. So
That sounds fun. It's
It
better than homework.
yeah, it actually is pretty fun doing wedding planning and everything.
So I do have a question, Gavin.
What's up?
So question 3 is asking, for those 2 parts, evaluate this control variable using the methods used in class. So in that section, we're just supposed to talk about the p-value and r², right? And then just seeing if like the slope changed.
Correct. Yeah, that's all that I think he is actually looking for,
Mm-hmm.
because that's what he taught us.
Yeah. And then when we, kind of like just from what we saw and everything right now, and comparing the new equation while controlling for women ledge, that's just basically the part that we're answering for part B, right? Like how it didn't really help us understand the relationship much better.
Correct.
Okay.
Well, it did not improve on the relationship and help explain the relationship. The only thing that it did was help us understand that the women ledge has nothing to do with this relationship. That's the only way it helps us understand the relationship in a better way, is that women ledge has nothing to fucking do with it.
All right, cool. Thank you.
Not a problem. Anything else? We got about another minute and a half before Zoom's going to kick us off.
For the extra credit, do we have to read all of them?
I don't know for sure, but I have a feeling that it's just going to be, have enough to talk, read enough so that you can kind of chat about it.
Mm-hmm.
And, maybe raise your hand once or twice, and then you're probably good.
Okay.
All right. Well, once again, thank you, Gavin.
Thank you.
Not a
Yes,
problem.
thank you.
I'll once I get this posted up to YouTube, I will send the link to the chat for everyone else.
Yeah.
Great. Thank you. You all have a good night.
You
Bye.
too.
Have a great
Thanks.
one.
Bye.
Bye.